review, we'll basically solve multiple problems together. This lecture will start with the problem of differentiation, so finish the topics that we started last time. And after we do this, we'll just solve problems on different topics, different types of problems. Maybe problems, some of which will be same level of difficulty as the ones in the exam, some will be a little bit more difficult. Just to see what we can do. So let me start with the problem on VC differentiation first. So let me recall that problems on implicit differentiation is useful whenever you want to find tangent line to a curve which is given by some equation. So a typical problem on such topic would look like this. Find the equation, or maybe the slope of the tangent line to the curve given by such an equation, 1 of y is equal to x times y plus 1 at point minus 1 comma 1. So since this time, well, obviously the last week, so there aren't that many of you this time, maybe let me give you a couple of minutes just to start thinking about this problem. I'll walk around and see what kind of problems, where are the places where you get stuck, and then we'll discuss this problem, well, I guess in 5 minutes together. So please start. You're free to discuss it with your neighbors. Just make some advances in this problem. And if you are stuck, raise your hand, I'll come and try to unstuck you.
Oh, it's just the last page. side you're doing, the left side is chain rule as well. So 1 over y times this. No. Y is a function as well. Oh, no, it's not a function. Never mind. Yeah, so it's, yeah.
Also, if you have an answer, please also raise your hand. I'll come and see.
Yeah, I think it's sometimes. So that's the square root of cos, which is times x stays the same times 2x, so that's x squared.
Once again, if you are stuck, raise your hand and I'll come and give it to you. Yeah.
But it's times. Because I guess the root of y is 1 and also plus 0.
Oh, so here, 1 of y, it's not quite 1 over y. The reason is because y is a function of x. So to take longer of the function of x, because y is continuous. So we have 1 over y, that multiplied by the derivative of the function, multiplied by y time. So from here, we should solve for the y time. What is it here? And what was
Okay, so I see that most of you advanced quite a bit on this problem, so let's start discussing it. So, first of all, some things that I seen, well, people start doing which ultimately did not work. And it's important to recognize those because, well, you don't want to spend too much time on ways that will not work on the exam. So, you look at this equation and you think about the tangent line. Well, tangent line naturally leads you to the question of what is the slope of this tangent line. And the slope of a tangent line brings you to the question what is the derivative of y. So y can be expressed as a function of x, at least in small neighborhood of this point, minus 1, 1. And then the question is what is the derivative of y as a function of x. So one natural way to try thinking, but which ultimately doesn't work in this case, is try to explicitly write y as a function of x. Try to find the formula for y as a function of x. And I've seen people try, well, to take e to the power of both sides, try to bring 1y to one side, xy to the other side. The problem is this equation is really complicated. It involves both y, 1y. It's not one of the really familiar equations like the linear equation, ax plus by is equal to c. It's not a quadratic equation. It's hard to solve. Maybe in this case, it's actually impossible to solve in elementary functions. So this way will ultimately not work. What will work is what we did last time. In the lecture where we had, if you recall, we had an equation of a circle, and we had two ways to approach the problem of finding detention lines. One of the ways involved actually writing y as a function of x. The other one involved just assuming that y is some function of x, and then trying to work from there. Trying to work as if it is a function of x, and then we differentiate maybe the equation that this function satisfies. This equation in this case. So the first step here would be the following. Let y of x, so we'll regard y as a function of x. That's the name that we'll give to this function, y of x. Be the function satisfying y of minus 1 is equal to 1. This condition means when you plug in x equal to minus 1, the output should be 1. This point should be on the graph of this function. And also this function should solve this equation. And logarithm of y of x is x times y of x plus 1. So you assume that you, well, have a way to work with this function. You call it y of x. From here you want to find the derivative of this function, to find the slope of the tangent line to the graph. Well, so what should I do with this equation to find some information about the derivative of y? Derive both sides. So I take this equation. The left side is equal to the right side for any value of x. Both sides are functions of x. So at any point x, not only the functions are the same, but also the derivatives are the same. Because well, the functions are the same at every point x. So you're deriving the same thing. So the conclusion would be derivative of 1 of y of x is derivative of x y of x plus 1. Okay. Next part, I want to simplify this expression as much as I can to, well, with the purpose in mind to isolate y prime. That's ultimately what I want to do, to find what y prime is. Let's simplify this expression. Derivative of 1 of y of x. How can I find this one? Chain rule. Yes. So here, what will be the answer? Or, well, let's write it really slow. Derivative of 1 of y of x. Well, we have an external function, which is logarithm, taking the logarithm of the argument, and the internal function is y of x. It is true that we don't know a formula for y of x, but it is still a function, some way for y to depend on x. And then we apply the chain rule. du by dv is 1 over v, dv by dx is y prime of x. So this thing is 1 over y of x multiplied by y prime of x. Okay, so the left side there was 1 over y of x multiplied by y prime of x. The right side, how do I differentiate x times y of x plus 1? Yeah.
The sum of two derivatives.
Okay. So I have the last operation that I have here is a summation, this plus. After I compute this expression and that expression, I take the sum. So I apply the rule for the sum. Derivative of the sum is sum of two derivatives. X prime plus 1 prime. Now we are left with these two expressions. First expression, x times y of x prime. Product. That operation I have here is the product, so I apply the product. Derivative of x is 1 times y of x plus x times derivative of y of x. And 1 prime, what's y prime? 1 prime? 0, because 1 is a number. It does not depend on x. So plus 0. So from here to here, we just used our rules for differentiation to simplify this expression. Next step, isolate y prime. Try to solve this equation for y prime. So, what should we do? Here I have an equation. I want to solve for y prime. Yes. So it's always the same thing in these kinds of problems. Once you arrive at an equation which involves y prime, x and y, what you do is move all the terms which do involve y prime to one side, all the terms that don't to the other side, factor out y prime, and then solve for it. So let's do it here. 1 over y of x, y prime of x, minus x, y prime of x, is equal to y of x y prime of x times 1 over y of x over y of x minus x is equal to y of x. And finally we get an equation for y prime of x. It's y of x over 1 over y of x minus x. So now we have an expression for y prime of x. Are we done? We found what is y prime of x. Is it what we were trying to find? Okay, yes. So this would be the expression for the derivative or the slope of the tangent line at any point x. That's not what we want. We want one specific point, minus 1, 1. So next, plug in x minus 1. So for this point, the x value is minus 1. Y prime at the point minus 1 would be the value of y at the point minus 1, which you get here, is 1, divided by 1 over the value of y at the point minus 1, which is 1, and minus the value of x, which is minus 1. So we get that this number is 1/2. Are we done now? Now we know what is y prime at point minus 1. Is that the answer? that's not the question, that's not the equation. So the question is always when you feel that you are done with the problem, I mean, it's always satisfying to do a long computation which ultimately works, but on an exam, you should always ask yourself, is this what I have been asked? So, is this what I've been asked? Is the derivative of y point minus 1 the question? Well, no. The question was, what is the equation of the tangent line? What we found is the slope. So from here we should still go on and find the equation itself. How do we do it? Point and the slope. Okay, so I have an equation, I have a slope of a line, and I have a point on this line. This point, minus 1, 1. So, equation of the tangent lines it has slope 1/2 passes through minus 1, 1. So what is the equation?
Times x plus 1,
1/2 times x, let me write it as x minus 1.
and then plus 1.
Okay, so let me write it is y, or in other words, y minus 1 is x 1/2 times x minus 1. Thanks. So that's the equation of a line with slope. In general, if it was slope m and the point was a comma b, it would have been y minus b is m times x minus a. That's what we discussed basically in the first lecture. And that's the equation. You don't necessarily have to simplify. I mean, you could simplify from here to write that this equation is the same as y equal to 1/2 of x plus 3/2. You don't necessarily have to. If the question doesn't ask you to simplify, just leave the first version which doesn't involve expressions which you didn't compute yet. So you can write this equation as y minus b for some b, but if you have just numbers as the coefficients, that's all right. The only exception would be if you actually, so if you have a problem with, which is a long problem, and this is just an intermediate answer, which you will use later. In that case, well, for your own benefit, do simplify it more, so it will be easier to work with. Okay, so please questions about this problem. Anything which was unclear, or I don't know, maybe somebody tried to solve it in a different way, or any comments from trying to solve it. Okay, so with this problem we basically conclude the topic of implicit differentiation and conclude the discussion of the material for this term. So from now on we'll discuss just problems about the whole material of the course. Everything we did from lecture 1 to, well, up to this point, lecture 33. So for today I planned a question which will involve quite a lot of different topics. We'll discuss what topics exactly in a second. Let me formulate the question. Assume the population population at time t is 6 over 1 plus e raised to the power minus t over 100. And population in country B grows according to formula the population at time t is e to the power t over 1000. The question is to show that at some time t between 0 and 1000 the population populations grow at the same rate. So let's read the problem. We have two countries, A and B. And at these two countries, they also know what is the population in each one of these two countries at time t. For the first country, it's 6 over 1 plus e raised to minus t over 100. They are not given what units, so probably it's something like millions of people. And in the other country, it is e raised to the power t over 1000. And the question is, show that there is some time t, in fact, not just any time t, but time between 0 and 1000, for which the rate of growth of population in country A is the same as the rate of growth of population in country B. So, before we even start, well, writing anything, before we start computing anything, I want us to come up together with some kind of plan. What things, well, what steps should we undertake in the solution of this problem? Maybe identify topics which we suspect that this problem will be about. What kind of theorems, what kind of computations we'll have to perform, what kind of theorems we'll have to apply.
IVT.
Okay, so intermediate value theorem. What gave you the idea that intermediate value theorem might be applicable?
Because just the fact that the two kind of, if you equated them to graphs, they have to cross at some point. Because I assume one's going higher, one's going lower. Or maybe not even that. Just at some point the two graphs will intersect.
Okay, yes, so really good observation. The problem, the question itself asks, show that for some particular value of the parameter, some two quantities are the same. Such kind of question, there are basically two options for showing such a thing. One option would be to write expressions explicitly for these quantities and try to solve for the value t. Make one expression equal to the other expression and solve using algebra for the value of t. The other option would be a more implicit one. Try to approach this using the approach we've seen in intermediate value theory. Try to show that one quantity starts low, goes high, the other quantity starts high, goes low, and somewhere in between they must be equal to each other. So let me write some ideas.
What is it, the slope of the tangent line?
Same thing?
Isn't it the slope of the tangent line that you
Yes, that would be the next idea. So first idea was an equation show for some t between 0 to 1000 saying something. So equation which has basically this kind of pattern. Show that for some value of the parameters, two quantities are the same. It quite likely is about intermediate value theory. Or maybe some algebra. So what do I mean by algebra? Well, I mean solve the equation, some formula is equal to some other formula. So basically I have two approaches which you are familiar with. Either try to explicitly find the t or use intermediate value theory. Okay, so in either case we will have to apply either intermediate value theorem or solve this equation with some functions, with some actual, well, we'll have to equate something. What do we have to equate? So here the question is showing that at some time t, the populations grow at the same rate. So what is the same? Okay, so in the this it's the rate of growth. And the rate of growth, so rate of growth, so I heard the slope of the tangent line. Okay, that's good. What is it in algebraic terms? Do you have a question?
Yeah, I just have a question. Is your f of t how fast it's growing, or is it the population?
It's the population itself. Thanks. So it's the population at time t. So in algebraic terms, what is it? The rate of growth, if I have the quantity itself and I want to find its rate of growth, what is it? Derivative, yes. Okay, so now we have basically a shot at formulating a strategy for solving this problem. We want to apply the intermediate value theorem or maybe some algebra to derivatives of f and g. So what would be the step? Well, first step, compute those derivatives so that we will actually be able to work with them. And then try to figure out which one of the two ways will ultimately work. So step one, so maybe first the strategy. Find f prime of t, g prime of t. Try to show f prime of t is equal to g prime of t for some t between 0 and 1000 using algebra or maybe intermediate value theory. So if one of these two ways works, then we have solved the problem. If both don't, well, we'll have to iterate once again and think harder to find a different strategy. So let's start. Derivative of f. What's the derivative of f? It's the derivative of 6 over 1 plus e to minus t over 100. How can I compute this derivative? Or rather, how can I start computing this derivative?
Quotient.
Quotient rule. Okay, so the last operation is a quotient. It's reasonable to try to apply the quotient rule. Let's do this. The quotient rule was derivative of quotient is derivative of numerator times denominator minus numerator times derivative of denominator over denominator squared. So let's apply. Derivative of numerator times denominator minus numerator times derivative of denominator over denominator squared. What about the first term here? What's the derivative of 6? And what happens to this whole expression? 0 times this,
It's all zero.
it's all 0. 0 times anything is 0. So it's 0 minus 6 times here. Derivative of 1 plus e to minus t over 100. What should I do? What rule? The chain rule. Okay. So first of all, there is the simple step of recognizing that this is a sum, so it will be the sum of two derivatives. Derivative of 1 is 0 plus derivative of e to minus t over 100. And to find this derivative, we will have to apply the chain rule, because it's e raised to some complicated expression. So next step will be about the chain rule. Okay, so chain rule. Derivative of e to its argument is e to the argument. We know that derivative of e to x is e to x. And then multiplied by the inner derivative, derivative of minus t over 100. So it's e to minus t over 100 multiplied by derivative of minus t over 100 is what is it?
Sorry, what's the question?
So here I'm trying to find the derivative of e raised to the power minus t over 100. I'm saying that this is a composition of e raised to the power, of which the derivative is e raised to the same power, and minus t over 100. So now I'm trying to write the derivative of the inner function, minus t over 100. What is it?
Negative 1 over 100?
Negative 1 over 100. Divided by this expression, e to minus t over 100 squared. And since we are now in the situation where this expression will be useful to us later, let's simplify it a little bit. So let's cancel out these minus signs. Let's write 6 over 100 as 3 over 50. E to minus t over 100 divided by 1 plus e to minus t over 100 squared. Now we've done some complicated computation. We computed the derivative of f. We should recall why we are doing it and what's the next step. Well, luckily we have our plan outline right there. The plan was find f prime, find g prime, and then do something with it. So the next step would be find g prime. Let's hope that it's even simpler. So it's the derivative of e raised to power t over 1000. What is the answer? Thanks, that's correct. So the answer would be the derivative of the out, once again, it is a composition of two functions, e raised to power, well, you can say b, and b is t over 1000. Derivative of e to the power b is e to the power b. So here I have e raised to the same power. And then derivative of t over 1000 is 1 over 1000. Next step, we want to try this expression equal to that expression. Any ideas? Which one of the two suggested ways should we try to use? Should we try to actually find the value t, or should we try maybe to apply intermediate value theory? How can we even start answering this question? Just any ideas? What would you be more inclined to do? And if you have a reason, even better. So I just want to have any opinions. What should I do? Should I try to solve this equation, that this is equal to that? Or should I try to go in a roundabout way using the intermediate value theory? Okay, so what we see is if we try to solve this equation, it looks like it is somewhat complicated. It involves e to some power. It's not even the same power, it's different powers, t over 100 and t over 1000. It involves quotient squares. It looks like a really complicated equation. It's definitely not one of the simple equations that we know how to solve. Not a linear equation, not a quadratic equation, not even a linear or quadratic equation about e to some fixed power. We have two different expressions, e to minus t over 100 and e to t over 1000. So I don't see a simple way to solve such an equation. This is equal to that. On the other hand, intermediate value theorem, well, it looks like it should be applicable. Why? What should we check if you want to apply intermediate value theorem? Recall that it wasn't applicable just to any two functions. There was some condition about these two functions. In fact, there were a couple. Yeah?
One has to be negative and one has to be positive, or one side or the other of the particular value we're trying to find.
Okay, good. So one of the things, if you want to equate two functions, you want to show that at one point one of them is smaller than the other, at the other point it's the other way around. So the graph of one of them crosses from low value to high value. The graph of other function crosses from high value to low value. Okay, that's good. There was one more condition. Continuity. So I wanted these graphs to be lines which I can draw without lifting the chalk off the board. Otherwise I can just cheat and make a jump exactly at the point where they should have crossed. Are these functions continuous? Yes. well, what could have prevented these functions from being continuous? Well, they're defined using expressions, well, analytic expressions using some formulas. There is a place where we are doing a dangerous operation. We are dividing. So when we divide by something which can turn out to be 0, we might lose continuity. Can this denominator become 0?
No.
Why not?
You can't take e to any power that would make it -1.
Right. In fact, e to any power is positive. So 1 plus it is at least 1. Okay, so let's apply intermediate value theory. G of t is continuous because it's given by an analytic expression, given by a formula, which does not involve any of the dangerous operations. The function f of t is continuous for a similar reason, but now we have to justify it a little bit. The denominator 1 plus e to minus t over 100 squared is not equal to 0 for any t. And both functions are continuous. Well, we're interested whether they're continuous on the interval from 0 to 1000, but these functions are continuous just anywhere. So they're really, really continuous. Next, we want to see whether indeed one of the functions crosses from a low value to a high value, and the other one from a high value to a low value. What values of the parameter will we choose? Well, it's a nice idea to try. We are trying to find t from 0 to 1000, so 0 and 1000 are already given to you. It might not be the ultimate idea that will work, but it's a place to start. So let's try endpoints t equal to 0 and t equal to 1000. We'll compute what is f of 0, g of 0, f of 1000, g of 1000, and then decide how they are related to each other. Is f of 0 larger than g of 0? Is f of 1000 larger than g of 1000? So it's good. Yeah.
Those should all be primes, right?
These are primes. In fact, starting from here, I'm talking about, thanks a lot. I'm talking about these expressions indeed, f prime of t and g prime of t. Thanks. Okay, so f prime of t, O of 0. I plug in t equal to 0 to this formula. I get 3 over 50. E to power 0 is 1. Divided by 1 plus 1 squared, so divided by 4. So 3 over 200. G prime of 0 is e to the power 0 times 1 over 1000. 1 over 1000. So at the point 0, which one is larger? F prime of 0 or G prime of 0? F prime of 0. Okay, let's compute the same at point 1000. F prime of 1000 is t over 100 will be 10. So it's 3 over 50 e to the minus 10 over 1 plus e to the minus 10 raised to the power 2. I can't simplify this expression too much, so let me leave it like this for now. And g prime of 1000 will be e multiplied by 1 over 1000. Now we run into an unexpected difficulty. We want to compare these two expressions, but we don't have a calculator on hand. But we still want to know which one is larger. They are not as simple as the previous answers, not just 3 over 200 and 1 over 1000. So how can we know which one is larger? Which one is larger? What do you think? Well, the answer is you don't have to know precisely what these expressions are equal to. You have just to estimate what is the order of magnitude. If one is obviously much larger, one is huge and the other one is tiny, then obviously one of them will be larger. What about this number, e to minus 10? How large is it? Order of magnitude. I don't want a precise answer, but is it, I don't know, something like 1/2, 1 over 1000, 1 over 1 million, 1 over 1 trillion? What's the order of magnitude? Small, yes. So it's really small. E, well, is a number between 2 and 3. 2 to the power 10 is, well, what is it? It's 1000. Yes, 1024. So 1 over 2 to the power 10 is already 1000. So this expression is smaller than 3 over 50 times 1 over 1000 and divided by, well, this is at least 1. So this is at most this quantity. And this is at least 2 over 1000. Because E is at least 2. So which one is larger? Of course, G prime of 1000 is larger. So we do have this situation. F prime goes from large value to a small value, G prime goes from small value to a large value. They are both continuous. By intermediate value theorem, they are equal somewhere in between. Okay, so thank you very much. Sorry for the